All right, let's continue on then and finish up this chapter. The next portion of the chapter starts talking about loops. And again, as you already know, loops allow you to repeat statements over and over again, either forever or a certain amount of time. Now, and I realize when I say this, I'm dating myself, but back when I was programming at AT&T Bell Labs, that was in the days of rotary phones. So you'd pick up the phone, you'd get a dial tone, and most people would wait 3 seconds for a dial tone. And if they didn't get it, they'd hang up the phone, thinking something was wrong. And the phone company potentially lost money then. So we had code that ran in what were called infinite loops. They had to be available 24/7. All right, some stuff is like that. Amazon's like that, right? They sell all over the world, and there's somebody awake at all times in some place in the world. So they're going to show in here a while loop, and I'm going to show it to you as well. But again, just like with an if, there's a condition and one or more statements that you put between curly braces. We're actually going to do something very similar to this in a minute, so I'm not even going to go through it right now. The while loop is called a pretest loop. So look at this example right here. Right there. Does it make sense that if instead of 1, if I was equal to 11, you'd never go into the body of this loop? Because 11 is not less than or equal to 5. Since it's a pretest loop, you check the value of the loop before you go into the body. If the value is true, you do the body of the loop, and then you go check it again. If you don't change the value, if we didn't do this, and hey, here's one. I forgot to do this in the example because I was just doing it right before you came back. Then it's an infinite loop. Because if doing it the way it is right now, it's going to say, okay, it's never adding 1 to I. So I is always 1, which is always less than or equal to 5. That's an infinite loop. All right. So the while statement creates a while loop that contains a block of code executed as long as or while that condition is true. Now, unlike a while loop, there's a do while. It's a post test. What that means is you always go through the loop at least once. So in this example, right here it says let years equal null. Here they're not checking what years is until the bottom, so you always go through it at least once. Sometimes what developers do is they want to check and make sure their error checking code, we're going to be talking more about that as we go on, but code that validates what you're doing. They want to make sure their error checking code runs so they can check it to make sure that when it runs, it's executing correctly. So sometimes rather than using a while loop, they'll use a do while loop to force their error checking code to run. Then once it's run and they validated the results, then they change it back to a while loop. Other than that, I don't think I ever used do while loops. And what you're going to see in just a minute is there's also something called a for loop. Now, the for loop is called a counting loop because you need to know exactly how many times you're going through the loop. And you get 3 different things in here. You initialize some kind of a loop control variable. You're going to see in the examples I've written for you, I typically call mine LCV for loop control variable. You can call it anything you want. This is considered the one time it's acceptable to call your variable something like XYZ or whatever. All right, but I always, in fact, I called mine in here LCV1, LCV2, and LCV3 because I have 3 different examples. All right, so here's where you initialize a variable. Here's where you test the variable. And here's where you change the value of the variable. So rather than doing it like you do with a while loop, where notice you've got it, you set the value, you test the value, you change the value on 3 different lines, and you do the same thing with a do while. You set the value, you test the value, and they didn't change it in here, but you would change the value. With a for loop, you do it all in one line. But unlike a while loop or a do while loop, with a for loop, you must know exactly how many times you're going through the loop. All right, you've got to know that. You don't have to with a while loop or a do while loop. So let's suppose that I was running through a whole stack. So let's say that I work for a company and, hey, I work for a bank and I've got all these deposit and withdrawal slips. Gee, Jeff, how many do you have? I don't know, but I got a stack this big. I couldn't use a for loop unless I counted them first and knew exactly how many there were. But if I didn't want to do that, I could use a while loop or a do while loop and say, while there's more things to count, keep going. All right. So the for loop is used when you need to increment or decrement a counter that determines how many times. Again, it's a counting loop. All right. So before we go into these three illustrative applications, which we'll do in just a moment, let's take a look, because I have written this. It's nothing earth-shattering, but I want to show you each one of these. This is the wrong one. So here is a while loop. Before you even type it in, if you want to do that, fine. If you don't, fine. Let's go over every line in here. So this is our loop control variable. This is the thing that's going to change as we go through the loop. So I called it LCV1, loop control variable 1. This, I only want to print out the numbers 1 to 10 once. I don't want an alert that prints 1, then a second alert that prints 2, then a third alert that prints 3, and I don't want 10 of those. So I'm just putting everything in something I called str1. So the first time through here, there's nothing in str1. So to nothing, I'll add the number 1 and a blank space. Then I'll run it again, and LCV is now equal to 2. So this will now be equal to 1 plus the 2. All right. Since this is a string, this LCV, all I'm doing is just printing out the numbers. So when I run through this, it's going to have basically the first time through right here, LCV is 1, so it's going to print out 1. Then the next time through, it's going to add a space. Then it's going to come back and put in a 2 and a space, a 3 and a space, all the way through 10. And that's all it's doing. So that is allowing us to do something 10 times. If I wanted to, instead of making it 10, if I wanted it to be 100, I'd only have to change this. I'd have a pretty ugly print statement. All right. I could make it 1,000,000 if I wanted to. It would take too long to run that, but I could do that. All right. And you'll notice here, we've already talked about this before, this line 37. We could have said here plus plus LCV1 or LCV1 plus plus or LCV plus equal 1 or LCV equals LCV plus 1. Any of those would work. Most people pick plus plus LCV or LCV plus plus for brevity reasons. Does that make sense? All right. Again, I mean, I don't want to see how many characters I can type when I'm writing a program. All right. The less I have to type, the less I have to maintain. It's kind of the way I look at it. So let me just show you this. I'll come right back to the program, promise, right? I'll come right back here. But I'm going to do a file save. I think I've saved. And I'm going to go over here and run it. Now I've got all three of them here, but notice what I get. 1 to 10. And we're going to look at the same program in just a minute with a for loop, and it's going to print out, here's a surprise, 1 to 10. And then we're going to look at it with a do while loop, and another surprise, it's going to print out 1 to 10. All right. So again, you know, if I don't know if that helps or not, but I'll put comments here. Set value of loop control variable. Set value of string to hold output. Test value of loop control variable. All right. And this is going to be increment value of loop control variable. All right. You should be able to look at that, and ideally, at least, it makes sense to you. All right. Now, as we go through this, there's some shortcuts and there's some tricks and some other stuff, and probably sometimes I'll remember to tell you about it, and probably sometimes I won't. All right. And if I don't tell you a shortcut or a trick, it's not because I don't want you to know it. I just didn't think of it at the time. All right. But looking at that, is there anything that's in there? Do you understand that what should print out right here in this alert is 1 space 2 space 3 space 4 space 5 space 6 space 7 space 8 space 9 space 10 without that N in there? That should be the output. And if you get that, there's no more to it than that. All right, so again, I'll put here output. But I mean, that's over commented right there, but I just wanted you to understand what's going on in every step here. Remember, again, the while loop is a pretest loop. So in other words, look on the screen. If I make this 11 right there, it won't print a flaming thing. Does that make sense? In fact, I'll tell you what, I'll change this right here, and I'll have the string here say while loop. All right, just on the output, so you'll know what each one is. See what I'm saying? And we'll put a space in there. So if I didn't screw it up, it'll now say while loop. There you go, while loop 1 to 10. Okay? And the reason I'm doing that is when I do the other two, I'm going to have it say for loop 1 to 10 and do while loop 1 to 10. All right? But again, this is one of those things that virtually anything that you do in programming, you're going to be using loops for in one form or another at one time or another, and typically on a fairly regular basis. All right, and think about this. What if I'm in charge of a payroll? Let's say, what if I'm in charge of the payroll program for Rankin? All right. Most everybody at Rankin, to my knowledge, they're salaried. We're not hourly here. All right. So they don't care if I come in at 8:04 or if I come in at 5 in the morning. I get paid the same regardless. But the point is, if there's 500 people working at the campuses at Rankin, they could pretty much run the same algorithm and run it 500 times. All right. That's why you use loops. Any questions on anything that's in there? All right. So here's the same thing with a for loop. So again, I will change this a little bit, but I'm going to put in here initialize loop control variable. This again, I'll say for loop, not full loop, for loop. And this will, whoops, come on. this will hold our output. All right. So what is this doing right here? Again, this is another pretest loop. But what is this doing? You should be able to figure this out. It is what? It is initializing, and we don't even need to initialize that up here. Do you see this? I could just leave that like that. I don't really need to initialize it because I'm doing it in the loop. Or look on the screen, please. If I do decide to initialize it like this, totally fine. But if I do initialize it to 1, then I don't need to do it again. I can write it like that. So you can do it either way. It doesn't matter. Or let's make it even more complex. I don't even need this flipping statement right here. I can say for let LCV2 equal 1. That's probably the best way of doing it because it's the least amount of code. So that one holds my output. This will initialize, actually declare, and init LCV. It'll test the LCV, and it'll increment the LCV. And this output. And it should be, again, for loop. 1, 2. Oops. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That should be the output of this now. You're all very trusting, but let's go back and just run it and make sure. So there was our while loop. There's our for loop, 1 to 10. In just a moment, we'll do the do while loop, which is right here. All right. So that's that one. And in the same way, if you just pause for a second and look on the screen, if I made that right here 11, right there, 11's not less than or equal to 10. It would never do this. So since I set str2 to for loop, all it would print out here would be for loop. Just to prove that, and I'll change it back, so the middle one should only say for loop. And it does. So this does 3 things. We're declaring the variable. Look on the screen, please. I want you to understand something because I didn't bring this up before and I should have. If I do this, if I say let age is equal to what? You should know this from yesterday. Undefined. This is called a variable declaration. All I'm doing is declaring it. Then if on the next line I say age equal 21, that's called a variable initialization. If I know the value to begin with, I can combine them and say let age equal 21. And if I do that, that is both a variable declaration and initialization. Okay? Sometimes you don't know ahead of time. I might be running a program, and let's just assume here that I have 5 classes. And maybe I've got a lecture that's got 100 people, and maybe other classes that go down to 10 people or something like that. Then I might want to ask when I run the program, how many people are in this class? All right? If you know, it makes no sense to do it like this. It makes much more sense to do it like this. Any questions on this one? Is there anything on this one that doesn't make sense? Because this is the time for you to ask. Everybody got it? Now, at the end of this chapter, they're going to introduce you to the topic of arrays. And if you say, I don't know what they are, I'm going to show you probably the same way I showed these gentlemen here that took the C# class last semester, because I think it makes a little more sense to see it the way I'm going to show it to you. All right? And the point is, there are special for loops that you can use only with things like arrays. They don't work with primitive values like we're working with now. They work with data structures or more complex type of values. Any questions on either the while loop that we looked at previously or the for loop? Anything? As I will tell you, you will be expected when you take your first test to be able to do an if statement as needed. There won't be anything on there with the switch because it wasn't in the book, and that wouldn't be fair. I've shown it to you, but that wouldn't be fair. That said, if there's something where you can use a switch and you want to, you can. That's not a problem. However, you got to do it right. You know, I've had that happen before when people say, yeah, I went and read ahead and I put that on the test. Well, you did it wrong. But you shouldn't take off because I read ahead. Then don't read ahead. If you read ahead but did it wrong, you're better off not reading ahead. You know, I've said this before, that you should fight for every point that you get. If you get your test back and you get 115 out of 125, you think that's not fair, it should be at 116, you should fight for that. That's your right. All right? But I always reserve the right that when that happens, I regrade the whole test. I don't do that looking for more to take off. I do it just to make sure I haven't screwed up any place. That's all. All right? And again, maybe these guys have heard this, but I'll always remember this. Is Jim Newcomb. He was one of my students when I was teaching in Stevens Point, Wisconsin. Terrific guy, really, really bright. But he came up to me after during a break after I gave back a test, and he goes, "Can I just ask you a question?" He said, "You know, I don't know what the grade was, but he said you took off, and I added, and I didn't see where the problem was. You know, this one, it didn't look like it was wrong. And I looked at it, I said, you're right." And he said, "Oh, good, you're going to change it?" And I said, "Yeah," but I said, I'm going to go back and regrade your test to make sure I didn't screw up anything else. You can't do that. I said, "What?" He goes, "You can't do that." And I said, "Says who?" And he said, "Says me." And I said, "Well, who's the teacher?" And he goes, "You are, but you can't do that." And it got to the point, and he had never been a problem in the class, ever, and was never after that. But he said, "You better watch what you're saying or I'll effing pound the hell out of you." Basically, is what he said. All right? And I'm like, why don't we just go outside? Not to fight, but I just want to know, well, what had happened was he found out the night before that him and his wife were denied for a home loan. And he needed someone to take it out on, I guess. So, 5 minutes later, everything was fine. I was glad. I don't know who would have won, to be honest with you. Back then, I didn't have this fat, so it might have been at least an interesting fight. Who knows? All right, so everybody's got it now? Yeah. All right, so here's the last one. Here's the do while. So I'm going to change this and have it say do while. And again, just like we've done before, so this is our loop control, whoops, declare, not del care, declare and initialize loop control variable. This will declare and initialize our output variable. This will test our loop control. I'm sorry. Hold on, because this isn't written right. That's what happens when I just do a copy. This should be the word do and nothing else on here, because otherwise you're writing the same thing you wrote before. And the while goes there with a semicolon on the end. So this is testing the loop control variable. This is changing the loop control variable. And this is, for lack of better words, we'll say setting the output string. And this will print the output. Now let's make sure, and you're all trusting, but let's make sure I didn't screw it up. This is a post-test loop. So let me grab these two alert statements that are here. I'm just going to comment them out for now. All right, and then come back here and make sure that it worked. Do while 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it works. All right, so I'll leave that up there. I'll give you a couple minutes to put that in if you want to. So again, tomorrow we will go over chapter 4. Thursday and Friday will both be labs for the entire period. All right. This is the only time in any of these loops where you put a semicolon on the end, like I've shown right there. It won't work without the semicolon, so you know that. And I think these guys would tell you that these are the same 3 major loops that you're going to use next semester when you get into C#. They work pretty much exactly the same way. I probably used the same type of example last year when I explained it to them. And the good news about that is that means now, if we have new people who join in spring, then I have to go over it all over again. But if we don't, if it's the 3 of you here, then we'll go over it, but we'll do it much quicker. All right. It's like they were the 2 newbies last semester, and that's why we went over all of it. Of course, there were a couple people who were in that class that aren't in there anymore that thanked me afterwards for going over it again. So, all right. Does everybody understand the difference between the 3 loops? If I put an 11 in here now, it's still going to come through and print out do while 11 because it doesn't make the check till the bottom of the loop. Just to prove that, if I save it and run it, do while 11. It's a post-test loop, so it does not check the value of it until the end of the loop. All right, so you are guaranteed with a do while that it will always run at least 1 time. All right. All right, so then they give you 3 illustrative applications. We're going to look through these, but fairly quickly here. All right. So, well, notice what they have here. They've got a do while loop, totally fine the way they've done this, just so you know, totally fine. And they say it's allowing you to do the program more than once. You see see how the whole thing is in a do while loop? See that? Now, what aren't they doing here? Well, they're saying const miles equal parse int prompt. You know what that means already. They're assuming you're going to put numbers in there for both of those. If you don't, it's going to take NaN and divide it by NaN on this line that's right here. All right. So really, they could have used a while loop inside of here for each one of these, as I showed you earlier. Would have made it a little cleaner, and it would have worked then. Plus, we could have set minimum miles. We could have set maximum miles. In fact, what I'm going to do is I'm going to take their example here, not right now, but I'm going to take their example, and I'm going to rewrite it, and that's how we're going to start tomorrow's class. Because the idea is it will show you loops, and it will show you an if, all right, with some else statements, etc. in there, plus we'll use consts, all right? So what are we doing here? Telling you to read in so let's say you put in 300 right here, okay? And how many gallons did you use? We put in 22. Is miles greater than 0? Yes. Is gallons greater than 0? Yes. So they're only doing this stuff, I guess it will be okay, because they're only doing this stuff if both of them were positive. If they're not, it's going to say one or both entries are invalid. Now, this is kind of an important thing for you to realize, because this is the kind of thing that you would do if you were writing a login program where somebody had to put in their login and password. You wouldn't want to say here, you wouldn't want to check and say here, you wouldn't want to check the login and say, no, the password's okay, but the login's bad. You see what I'm saying? All right. You'd want to do something like this where it says if either one of them was wrong, you'd say one or both entries are invalid. All right. And then they're asking if you want to do it again. When I show you this tomorrow, I'll show you a way that I think it's a little nicer way. It reads a little nicer. But there's nothing wrong with this. Not at all. The point is you should be able to look at this now. They're actually writing the HTML out here. I don't know why they did it like that, but they did. And when you use the backticks that I've shown you, those template literals, you can put HTML in there. All right. So, again, that's assuming like, if you put in 412, you get this. 350 and 9, you get this. They did it 2 fixed to do it to 2 decimal places. All right. Then they've got this future value application. What that is it says, for example, if you invest $10,000 at an interest rate of 7.5%, like that's possible, all right, and you do it for 10 years, that's how much money you should have. All right. So again, it's very similar to the last one, except notice they now have done do whiles, so they've done it a little bit better for the investment, and another do while for the rate, and another do while for the years. So you can be sure by the time you get down to here, you have values, all right, that are numeric. What's wrong with that? Well, look, all they're checking for is not numeric, or is not a number. What if you put negative numbers in for one or more? I don't think right now this checks it. All right. So you'd probably want to use some constants in there to show minimum and maximum values. All right. And then they've got the enhanced test scores application. So again, you put in 3 scores and it gives you the average. But now they're letting you do a couple things. All right. Notice they're coming in here and they're saying enter a test score or enter -1 to end scores. All right. So if you put in -1, in other words, you're done. Make sense? So let's say we did put in a -1. Score is not greater than 0, so that's going to be skipped. We'll do this. If it's not -1, well, it is. So we wouldn't do this. So while score not it is -1, so we'll fall out of the loop. So if we put a -1 to begin with, we're going to fall out of the loop. But since we've got these all set to 0, all right, it'll just print out 0 for everything. And unlike other languages, some computer programming languages, if you attempt to divide 0 by 0, the answer is infinity. It attempts to try to figure out infinity for you. All right, JavaScript does not do that. It will tell you infinity. It doesn't attempt to do the calculation. All right, so look through these 3 programs, and if there's something in there that doesn't make sense, I'll try to remember to ask this tomorrow, but ask, and I'll be more than happy to go over them. All right, so this is how I'm going to explain arrays to you right now. Good, bad, or indifferent. When I moved here, now about 6+ years ago, my wife decided to stay in our house in Illinois because I had a daughter who was going to college then. She had 1 more year to go. All right, so it ended up that her 1 year ended up taking closer to 2, so I lived in an apartment for 2 years by myself. All right, and so imagine, we're just pretending here, this wasn't the address, but let's say I lived at 123 Main Street in Wentzville, Missouri 63385. All right, and where I did live, it was an 8-person unit. It was, and I was in apartment 1. So we have 1, 2, 3, 4, 5, 6, 7, 8. So I lived in apartment 1. So in there was Scott. I'm going to make these up. I didn't know any of my neighbors. All right, except one guy had somebody break into his house, so I got to meet him that way. Jones, Black, Brown, you see I'm being really original here, Green, White, Smith, Johnson. All right, so if you can imagine, if somebody sent mail to 123 Main Street, apartment 1, I'd get it. Does that make sense? I found out after I bought the house I'm living in now in Lake St. Louis, I didn't know this ahead of time, it was a rental house. We have had upwards of 13 different people that we've gotten their mail. We've been there for 3 years. We keep sending stuff back. We keep saying does not live here anymore, but we get it at least once every time we get mail. It's for somebody else. And yesterday there was somebody we'd never heard of before. So my wife says, oh no, I know we're in the double figures. So, all right, so if they send it to apartment 2, but they put Scott on it, it might go to me. It might go to Jones. If they put 123 Main Street and they didn't put an apartment on it, and it was for Wilson, I don't know what they'd do with it. Typically what they did there was they would put stuff on the side. You know what I mean? Because we all had our little mailboxes, but there was a little side compartment there. All right? So, I mean, who cares? Well, let's imagine that I call this thing apartment. So I'm going to say let apartment. All right, apartment, I think that's right. Okay. And what I want to do is I want to be able to have it set up so rather than having 8 different variables, which is what I kind of been talking about now, I want one variable that has 8 different compartments in it, kind of like the one mailbox with 8 different slots in it. All right, so I'm going to do this. I'm going to say equal. Now this is only one way of doing it, okay? And I'm going to say apartment 0 equals Scott. And to try to make this go a little faster, so 1, 2, 3, 4, 5, 6, 7, and All right. Now what I've done is I've created an array. And it is one variable called apartment that has 8 different locations in it. The first location holds Scott, the second location Jones, etc. Now, if I knew ahead of time that these were the people who lived in here, if I knew ahead of time, I could have done this. I could have just come in and said, Scott, Jones, I'm not going to put all of them in, but you get the idea, right? All right. Not only that, when I did this, this is the easy way of doing it right here. But I can also say, if I want, new array. I don't know why you do that when you only have to type in bracket, bracket. I don't think I've ever seen that in any actual application code, but you can do it. Now, I bought a house, I moved out, and Wilson moves into my apartment, my old apartment. So now apartment 0 equals Wilson. Does that make sense? So imagine these were grades. Okay, let's just say for lack of argument, there's 8 of you in here. And I've got 8 grades. Rather than creating 8 different variables, where I put in Mason's grade, Michael's grade, Donald's grade, etc., I can have grade 0, grades 1, grades 2. And you might say that doesn't really buy you a whole heck of a lot. But imagine there were hundreds of you. I don't want to do this. Somebody else might. I might have a data entry person who does that. I don't know, but I don't want to do that. All right. The other thing that's kind of nice about this too is let's say I have a thing of grades. So I'm going to say here, let grades equal bracket. I can give it a size. So I can say there's 500 people in here. All right. And that would go from 0 to 499. Okay. And then I can come in here and say, I can use a for loop. For let LCV equal 0. LCV, now I could say less than 500, correct? I could say that. But arrays have a special property to them that's called length. So I could use the name of the array, which is grades dot length. So that's the same thing as saying less than 500. And then plus plus LCV. All right. Now if I come through here and I say this, grades LCV equals 0. Now what I've just done is I've zeroed out 500 locations, and I've done it with 3 lines of code. And if it was 1,000,000, all I'd have to do would be to change that to 1,000,000. In fact, I could come up here and use a const, and I could call it num students, and I could set that equal to 500, and then over here, I could make that num students. I mean, that's one thing you should always be thinking of, is ways to make your code easier for you and others to understand. Now you might say, well, that's more work. Well, you have to put it in there once, but let's face it, with IntelliSense that you've got in your editor, it's not like you're going to be typing it in all the time. Notice that if I, even on here, and this isn't the greatest editor, this is an editor, not an IDE, but if I put an N in there, notice it sees it. So I just hit tab. All right, and it's even easier when you use Visual Studio Code. One of my students asked me yesterday, they said, why do you sometimes use Visual Studio Code and sometimes Notepad++? Because I can do this as I need to. And I kind of like that. It's harder to do that in Visual Studio Code. You've got to go into the settings to change it. All right. So with all that said, an array is an object that contains elements. So each mailbox or each family that was in the first one I showed you was an array element. Each grade was an array element. So when you look in here, again, you can say new array, and I don't know if you have to give it a length or not. I didn't, but there. Here I know you don't. All right, and this is kind of what I showed you. So you can do it that way, or you can do it this way. You can have an array of numbers. You can have an array of strings. You can have an array of Booleans. One thing that is different from JavaScript than most other programming languages, in most languages, like C# that you'll learn next semester, if I have an array of ints, they all have to be whole numbers. If I put something in there that's not a whole number, it'll break the program. In JavaScript, the array can hold anything. So I can have the first element can be a number, the next one can be a string, the next one can be a Boolean. You can do that. I wouldn't recommend doing that typically with an array, but you can do it. There might be a reason actually for doing it. So an array can store one or more elements. The length is the number of elements in the array. All right. Each thing that's in the array is called an array literal. The first array index is 1. The last one is the length of the array minus 1. Loops for arrays, I've kind of shown you these already. For loops work great. It's not that you can't use a while loop. It's not that you can't use a do while loop. But with an array, you typically know how many elements are in there. You should anyway, so it makes it easier. Now, goofy thing about JavaScript. Okay? So I'm not gonna do this. I'm gonna get rid of this. Okay? And I'm going to put in here 500. I probably could have left it in. Okay? But what if I do this? So I said the array was size 500, and I only put in 100. What do you think is going to be in the other ones? Close. Undefined. We haven't given it a value. Not only that, and this is pretty unique to JavaScript, there's very few other languages that I know of at least that allow you to do this. So I said let grades equal, I'm not going to put a number in here. All right. So now it thinks that I've got an array with 100 values in it. Does that make sense? So I come in here and I say in the next line, grades 999 equals 71. I just made that up. That's legal. Now, 101 to 998 have undefined in them. But you can do that. Again, it's not something you necessarily would want to do, but you can do it. All right? When you use a for loop to work with an array, you can use the counter for the for loop as the array index. It's kind of what I showed you. Now, there's a couple special for loops that you can use with arrays. And they are a for in and a for of. Why would you use those? Because typically it results in a little less code. So look at this. We are creating the variable I right there. So right there where you see it in gray, that's creating the variable I. All right. So this is assuming that we've got, there's totals. So it's got those values in there. For let I in totals, sum plus equals total sub I. Okay, totally fine. But let's break this down to see what this is doing. So sum here is being initialized as 0. All right. For let I equal let I in totals, says start with the first element. So the first time through, it's 141.95. Well, sum was 0, so it's 0 plus 141.95. Then you run through it again, and now sum is 141.95 plus 212.25. All right? And it's totally fine. Sometimes what you end up seeing in here with some of these loops is people will take their arrays and they will make them plural, like totals. Then they will call this the singular. So they'll say for let total in totals. See that? If that helps, use it. If you say, no, that makes it more confusing, then don't use it. So that is a for in There's also a way of doing that with a for of. So what's the difference? All right, it says there in a for in loop, you declare a variable that stores the index. So this is the index. That's why it's I there. All right, in here, it's not the index, so it's not these, the 0, 1, 2, or 3, all right, but with the for of, it's the values that are associated with them. So the for of, you declare a variable that holds the value of the current item. They work very similarly to one another. They will both display the same total at the end. All right. So they go back and they do the test scores application again, and they do that using an array. I'm not going to go through that now because we're going to have a whole chapter on arrays later. All right. So, sort of lied to you. I didn't mean to, but I started looking at the homework, and it's all over the place in the way they've laid it out. So I'm going to look at it and let you know tomorrow exactly what the homeworks will be. All right? Because there's like sometimes they grab stuff from the book and sometimes they didn't. I thought it'd be a little more consistent. So I'm going to look at it. I promise I'll have that done by tomorrow. I've started to look at your homeworks. All right, so some of them I got done, some of them I didn't get done. All right, I'll try to get all that stuff done by tomorrow as well. All right, so again, tomorrow then, we're going to do two things. So as that moves, come on, there we go. The first thing we're going to do is I'll go back and either I'm going to use that, probably the miles per gallon program, because at least it's in your book. We'll rewrite that and talk about a different way that it can be written. All right? Then we will go over Chapter 4. Chapter 4 is going to talk, probably the hardest thing in here, at least to start wrapping your fingers around, your head around, is going to be event handling. Because you use some code in here that doesn't look as straightforward as probably the code we've looked at so far. All right? So we will go through Chapter 4 tomorrow. It's a little longer chapter than the one today. Again, Thursday will be lab for the entire period. Friday will be lab for the entire period. I'm going to send this to you, but I wanted to make sure first I had the right dates and the right everything in there. So today, Chapter 2 in lab. Yesterday, Chapter 2 in lab. Today, Chapter 3 in lab. I'm going to probably push this off, and I might even push this off till the 15th. I would rather take a little more time, have you understand, and do well with this stuff than throw it, slam it down your throats. Now, so lab Thursday and Friday. Next Monday, I'm going to give you a pretest that will be very similar to the test. As we've done before, I'll give you probably till from about like 8:05 till 10:30, quarter to 11. Then the rest of the period, I will go over that. All right? And that should pretty much prepare you, I would think, for taking the test. And then Wednesday of next week, we'll go over Chapter 5. I didn't do that right, see? 6 and 7. All right? So let me double check on the dates and everything that's in here, and I'll send this thing out to you then. All right, so the rest of the period is lab unless anybody had any questions. Yes. Did you say you have tests? Yes, I'll give you those back right now. You can take a quick look at them. Some of them, with some of you, I wrote massive comments. Sometimes I didn't. Probably the biggest mistake people made, I took off. Hey, you were told to make a Jumbotron on the first 2 pages. If you didn't make a Jumbotron, you lost points. I don't care if you know how it looked, because part of it was being able to follow the directions. All right. So what I did is I did a view source on everybody's, and if you didn't have a Jumbotron in there, you lost points. I believe on the last page it didn't say anything about a Jumbotron. All right. So that one it didn't matter. There's nothing to take off for on there. And again, I'm not doing this with the idea of, hey, let's see how many points I can take off. But did you follow the instructions? All right. Yeah, I'll give those back right now as soon as I save this.